Hello Internet. Please be aware that the two demonstrators in this video are childish kids with a very limited understanding of actual proper chemistry. If you want to play with the things we were playing with, be more careful than we were. Please enjoy the video. Hello.
Hello.
This is Monday afternoon chemistry, and we are going to try and react some hydrochloric acid with some tin foil.
Aluminium.
Aluminium foil. Yes.
And we're doing this with the gorgeous Matthew Plato.
Yeah. Gorgeous.
And the silly Emily Paul. Hi.
We've got this little piece of tin foil. I'm tearing it up to increase the surface area, and then we should add our acid.
Da, da,
As
da.
you will no doubt recall from chemistry,
If you did it.
increasing the surface area of something will hopefully speed up the reaction. So we won't be sitting here all day
On the toilet.
watching little bubbles up here. I think that's enough acid for a first attempt.
You mean enough foil?
Enough for it, yes.
Right.
It's snowing still.
We're doing it in the bathroom for safety reasons, so that we have the extractor fan and the open window.
Yes. Hopefully no one underneath gets pour anything.
What the blow?
I'll use this so that I don't have to hold.
Do you want me to see if I've got marigold gloves?
No, I'm good.
Don't pour this on anyone.
Are the light levels good?
That level perfect.
I could pipette some in.
Excitement. And then get the pen.
I put the acid down there. It's 1 mole of acid, so you know it won't hurt you that much if you get in your hands, but it's probably not a good idea to do it.
You still shouldn't do this at home.
No matter how much fun it is. We'll use enough of the acid so we've got some left. Here we go.
That's exciting.
I bet something's going to start happening in a second. Let's poke it down. But unfortunately it's not reacting as strongly as I thought it would. There are some bubbles, but
We are storing it to see if the reaction will progress after a few minutes. In other words, so far it's failing. No offence. You're not failing it yet, I'm joking.
now shall we use the measure
Let's use the measure.
to spoon in some iron
Can
powder?
I do something?
Sure. Open the iron. This iron. Yeah,
It's got childproof lock.
it's limaille. How do you say it?
Limaille de ferrure. De fer, even. Limaille de fer. Because this is from France, where I used to live. Would you like to hold that while I open this?
So this is iron powder.
I really want to sniff it.
Iron powder. You probably wouldn't smell of anything. You might get.
off my
You just
nose.
get a sniff of
Probably.
iron. Yeah. Yeah, you can order these things from everywhere. You can buy very powerful stuff in some places. Like apparently you can buy sulfuric acid from B&Q for unblocking drains.
Fair enough.
But that's the thing that I saw this video on. They put some of this drain cleaner, with a lot of tin foil, and after like 5 minutes the bottle just exploded.
Shite. That's not going to just explode, is it?
No. Besides the gas can escape, or a gas is being produced. Maybe a tiny bit of hydrochloric acid, hydrogen. Won't take so much this time. Let's have a look. Unfortunately, iron isn't the most reactive of metals, which probably why it's not doing much. But there's some bubbling. See?
Yes. You probably can't know the camera quality, but yeah.
There's quite a few bubbles being produced.
It's fizzy.
So what we're doing is we are producing hydrogen and iron chloride.
I'm going to do that.
Any children watching, please remember to write down the displayed equation
But don't try this at home.
and balance it with the correct number of moles.
I think it might be a redox reaction, but then that might be wrong. Is it a redox reaction, Matthew?
No.
It's not a redox reaction.
Iron is being oxidized, but I don't think anything's being reduced.
Oh.
No. Hydrogen is being... You are right, yes.
Yeah, I was right.
The hydrogen is going from a +1 reactive valency in the hydrochloric acid to a 0 reactive state, 0 valency, being released as hydrogen gas, whereas the iron is going from Fe, nothing, to Fe2+, plus, is reacting with chlorine, or the chloride ion. And it's actually producing quite a nice effect. You can still see it bubbling away. Don't worry, we're not going to produce any harmful amounts or anything, especially with a window with lots of snow outside. But I think our reaction is beginning to enter the running out of acid, but we are still producing a rather nice amount of hydrogen
So what's
gas.
what's the liquid still in there?
The liquid, I think, is the acid that's still reacting, and we're starting to produce a sediment of iron chloride.
Ah, let's see.
I'm sure that I don't know what iron chloride looks like.
Oh well.
I think it's a powder.
Possibly like that.
Yeah, I mean it certainly looks different to when we added the iron.
Should we have a look at how our aluminium is getting on? It's not really.
I think we can conclude that aluminium foil is probably got something covered on it. Still bubbling away nicely. What I shall do is just replace that back there to simmer,
Whilst we prepare our next
and we will
experiment.
see what else we can play with. Da 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 da.
This time I have the pincers. We are going to try and make that sodium.
It's not actually sodium hydroxide. That's what's written on there. It's calcium chloride.
We're going to try and make calcium chloride. Oh yeah, obviously, because yeah, with calcium hydroxide and hydrochloric acid.
Shall I open this for you? Push down and then turn.
You're not supposed to announce like how you open chocolate.
Then, shall we try 2 spoonfuls again?
Oh, there goes. Right, this is just limestone, isn't it?
Calcium hydroxide
No, that's calcium
carbonate. It's something.
Oh yeah, I can see some.
Quick lime, maybe?
Oh, maybe.
I forget the definition, the everyday valid things. Bubbling away.
Is it bubbling?
Yes.
Doesn't appear to be doing that much, to be honest. Very, very vexing.
Calcium hydroxide and hydrochloric acid, I would have thought would react rather nicely. Unless maybe that is reacting and we've got this stuff,
I suppose.
which is our pre-made calcium chloride, which is just dissolved in the water, which is the other reactive product.
And now looks like milk.
Yes.
Nothing.
Fortunately, I'm not sure what we can do to identify calcium chloride.
It's a mirror, is it going to change colour slightly? I'm sure it's a bit more yellowy than it was.
Really couldn't say.
Well, what about I don't know. That might be wishful thinking. Shall I stick it in the holder?
The simmering pot with our other 2 reactions. How's our iron doing? Unfortunately, you can't really see that, but it is bubbling away still
Yeah, it
quite
is.
nicely.
Actually, that's quite cool.
See that black stuff? That's our iron and rapidly forming iron chloride. And above that, I think you can just about make out some bubbles. Yeah, you can make them out on the camera. They're very blurry, but you can make them out. But to our eyes, it's very pretty because there are lots and lots of bubbles. So, I think we can say that our iron is either more reactive than our aluminium, or just in a more reactive state, because we were using powdered iron, and the best I could do was tear up the aluminium. So the iron has got a surface area far, far greater than that of the aluminium. But my A-level chemistry is not the best in the world.
No.
But yeah, that is very pretty.
Right. Right, Matthew just made me inhale some of that stuff, which you should never ever do because it's hydrogen and it smells foul.
We're sniffing hydrogen. Now, if you remember back to your school tests, I think you can do this thing called a pop test, which you should probably look up.
Nothing.
What?
Nothing.
What?
It's just like, which you should probably look up because you didn't want me to.
Huh?
Oh, never mind.
Yeah, it is. Yeah, it's the sort of same thing. You can do the sort of test for oxygen as well, but oxygen will be later. But if I remember...
It will make a big bang.
Yeah, let's pop a splint in. The sort of splint you find in a lab at school, in the chemistry department. Okay, nice. The wooden splint. Put it in, and you should get a little pop.
We're not going to do this though.
I'm not going to do that, but...
But if you smell it, it smells gross.
It smells a bit like hydrogen. I suppose it is hydrogen. It smells like hydrogen because it is hydrogen. And don't do this, but...
It's foul. No! I don't want to do it again! No! Is it safe?
It's perfectly safe as long as you don't breathe it in.
But I just did breathe it in because I'm to sniff it.
You will sniff it and don't breathe it in. Smell it?
How does that work? If you sniff it and don't breathe it in?
Let your nose gather, then puff it out again.
You can't do
Let
that.
the snow have it.
I did breathe it in before.
Did you smell it?
Before, yeah, but not that time. I'm scared!
It's perfectly safe.
Oh!
See? Good old hydrogen.
I think this seems to separate, and I don't know if it's because it's
Ah!
or if it's because it's reactive.
Oops. Bugger.
I can't believe you already sniffed that stuff.
If you start seeing pink elephants, don't worry. Now what I think what we've got is that calcium chloride is that sediment.
Ah!
And the water is... These are the three reactions that we've carried out today. We started by mixing tin foil or aluminium foil with 1 mole of hydrochloric acid, which didn't really do anything at all. Secondly,
Hurry up.
we attempted this with iron powder, and we got a much nicer reaction. It's still going slightly, but we've got a nice sediment of iron 2 chloride, and some hydrogen, which we've known to exist. And then finally, we mixed calcium, no we didn't, we mixed calcium hydroxide and hydrochloric acid, which I think, yes, is an acid-base reaction. So what we've formed is a neutral salt, calcium hydroxide, no, calcium chloride, and water. Very pretty. We'll see you again sometime for episode 2, and we'll see what else we can get our hands on, and we'll react then, in this very bathroom. Bye!
Bye! So, it would appear that if left long enough, it creates glitter! Would you like to say something, Matthew?
We'll see you after these commercial breaks.